I'm still in the not. You're telling me I'm still in the non-inertial reference frame? Yes or no?
So remember, the reference frame is where you view the motion
yes
from.
Or no, Zanuck?
So if you jump off,
Zanuck.
What?
Yeah, it's yes or no.
Well, it's a malformed question, as was said, but I'll try to describe best I can.
No, never mind then. It's not a malformed question.
If you jump off the same time that the ball is thrown, you will not see a deviation.
Why not?
Did you hear what I said?
You said you threw the ball, you see a deviation. If you jump off at the same time as the ball.
I'm on the roundabout. I throw the ball. I see deviation. I jump off. Ball's still in the air. No deviation. It's going straight. Am I still in the non-inertial reference frame?
You're not on an inertial reference.
My bad. In the non-inertial reference. Yeah. Am I still in the non-inertial reference?
If you change the way you think about it, you might stop using the wrong words.
Is it a yes or no, Zanuck? Am I still in the non-inertial reference frame?
Yes, of course you're in still inertial. Of course you are. Why would you be out of it?
I'm not seeing the ball's not deviating.
Doesn't matter.
I'm off the roundabout.
Then you're not looking at it from.
I'm not spinning anymore. I'm not even spinning.
But you're accelerating backwards, Jeremy.
You're not looking at it.
As you move backwards, you are accelerating.
I've landed on the ground. I've landed on the ground. I'm now still. I'm perfectly still. I'm not moving.
Okay, now you're on the ground.
And the ball's still going through the air. Yes, I jumped off as it was in the air.
Yeah, you're still in the non-inertial. You're still not in a non-inertial reference frame. Doesn't matter whether you jumped off or not.
I would say while you were in the air moving backwards, you were in a non-inertial frame of reference.
You're always.
You wouldn't see the Coriolis effect.
No,
but you would see other pseudo forces.
The problem is he's going back and forth between in and on. Jeremy, if you're in a non-inertial reference frame, okay, you're in it, and you're looking at the motion from that reference frame. You always stay in that. You and the ball are always in that reference frame. Now you're talking about looking at it from your eyes. Now the view. Remember where motion is being viewed. You would then you'd be going from an inertial reference frame or not inertial to an inertial reference frame. You would go from rotating to not rotating as soon as you jumped off. If you were viewing it like the movie camera. So the movie camera would see the ball deviate, and then while it's still in the air, you jump off. You just changed your reference frame.
Oh my God!
Just changed
you understand the problem with what you just said and what you've been arguing, and how that compares to what Jeremy's asking, and you don't understand why the fuck he's confused by what you're saying.
Well, I don't know how else to explain that. Go ahead, Slacker. You try.
Well, that's kind of the problem, though, right?
Don't talk. That's rule number one, Zanuck. Don't talk. That is the best thing you could fucking do for anybody if you want them to understand something. I am more fucking confused than ever about this shit. I never thought I was an expert. But what you're saying right now, to me, amounts to be an absolute pile of fucking shit.
Slacker, they're not simple concepts.
I'm just saying, that's great. You make it
clear as possible.
You're making it way more confusing than it needs to be.
It's not a simple concept.
It is.
Like playing a
it's
piano.
so simple. The merry-go-round spinning,
and now you're in the inertial reference frame. And even though you're still in the non-inertial reference frame of the rotating merry-go-round, now you don't see the deviation because you're still in the reference frame that you just jumped out of and left, and you're in the different reference frame now, you say. Come on.
Hey, Zanuck?
As soon as you're looking at motion, as soon as you're looking at motion and you're not rotating, so it transforms. It transforms from inertial to non-inertial observation.
Let somebody else who's capable of clear communication attempt.
That is clear communication.
Zanuck, if multiple people have told you what you're saying is not clear, what does a reasonable person conclude?
Just mute his ass.
If multiple people are telling you you are confusing, what should a reasonable person conclude?
A knowledgeable reasonable person would say that you're not explaining in a way that they can understand.
Okay, we're not knowledgeable. That's your job to make us knowledgeable.
Self-reflect a little bit, Zanuck.
You're incapable.
Self-reflect.
You tell me the error in that statement. When someone jumps off the rotating reference frame.
Nobody said there was an error.
Jumps off the merry-go-round.
I said jumped off the merry-go-round.
Right.
Now you're going to tell me you can't jump off a merry-go-round.
Of course you can, but you don't leave a reference frame by jumping off.
Right. You just went to the different reference frame, you said.
No, you don't go to a different reference frame.
Your words, dude.
You transform your observation from
Zanuck, your words, man. That's why I don't want to hear from you on this.
You transform from inertial to non-inertial.
Nobody wants to hear from you on this.
Oh, God.
Can you accept that?
All it is, all it means is that you're, if you're accelerating or not, if you're rotating or not rotating, that's what tells you what the reference frame is.
You, man.
Transform, translate.
Transform, yes.
When you say
transformation. Yes, it goes through a transformation. When you go from inertial to non-inertial.
What do you think they hear when you say that?
That it changes?
No, that's not what they hear.
You don't leave, you transform.
I know that, you know that. What do you think they hear when you say it? Communication is about being able to communicate to another real person, right?
They need a transformation.
Where is the changeless transformation?
You are not accelerating. You have no forces acting on you any longer. That's the transformation.
Oh, there's some powerful forces acting here.
Is that not? You're not no longer in that non-inertial rotating reference frame of the merry-go-round. It affects
your reference frame. Your reference frame is not accelerated anymore. You are not in. Hold on, let me finish. You're not in an accelerated reference. You're not in.
You know what, Zanuck?
Talking for a second.
What the fuck are you doing right now? I was expressing something when you decided that what you had to say was more important. I was
answering your question.
This was not a lag issue. This is Zanuck thinks he's so goddamn important that he's the only one that should be fucking talking.
Zanuck, just sit down for a while and let somebody else talk. You're being really annoying right now. Don't
really do want to hear from somebody else.
Hey, go ahead, take the helm then.
Do that with you fucking everything up.
Go ahead, then take it. Oh, you didn't mean to confuse anybody. Wasn't my intent.
You did. I know it was your intent, but it was your result. And you got to learn to accept that.
I'm accepting it. I'm frustrated I can't get the point across, but I will.
Okay. I understand it's frustrating not to get your point across. But you got to understand you're not getting your point across, and just doing the same thing
but I think
is not going to make it work.
You think you've gotten their point across to this guy? Has anybody got their point across to anybody?
No, of course not.
No, they're still flat earthers.
That's why we're here. That's why we're here to try. Makes our argument.
Well, I understand we're here to try, but we're also here to understand that when our method fails, that we don't just keep repeating it over and over.
I used a different method today than I've ever used, and it still failed. So I'm trying.
I know.
Call me for trying.
Okay.
I'm sorry. You know,
well, just add that to like the 10,000 methods, man.
And also, you know that they're here to try to make you flat earthers, right?
No, they're not. They're here just to be.
Yes, they are.
They're not going to.
They're here to make you mad.
They're not here to convert.
Bro, I'm not here to convert anybody. I'm just here to, like, in my head, when I hear reference frame, I picture a universal area of space that we all move through, right? I don't compartmentalize that and then say, well, I can view motion from one of the, no, I'm just like, we move around. And a merry-go-round, it's moving. It's an object that's moving. You stand on it. So when it's moving and you're on it, you're moving. When you're off it, you're not moving. It's simple. I don't need to say an inertial reference frame.
Did you ever take physics in high school or college?
No, I never took a. Okay. Come on, man. What does it have? What is it?
I just want to know.
Ask me a physics question. That's it. Okay, if you need to take a physics course to understand getting on and off a spinning merry-go-round, maybe you're dumber than you think you are.
Dude, he was just asking you a question. Don't get hurt about it.
All these tools are used for by people who understand physics is to do some mathematics and to understand where things are going to be in time. That's it.
Bro, but you're arguing over a reference frame.
If you don't need to understand where something is going to be in space at a particular time, then you don't need these things.
I know where it's going to be. I don't need math to know that if I'm on a merry-go-round that's spinning, I'm going to be where it's spinning to. I don't need some magical formula for that. I have a brain. I have an eyes. I can figure that out. You're turning it into this complex thing like, well, he couldn't figure out where he's going to be on a spinning merry-go-round. So we have to create an inertial and non-inenertial reference frame from which we view the motion from. It's ridiculous.
I'm pretty sure you couldn't map exactly where something's going to be.
You're teaching, you're making reality. All you're teaching is reality, but you have to make it so complex so you can make it seem like you know more than what you're looking at. When you say, well, there's an inertial, non-inertial reference frame, but all you're saying is a guy jumped off a merry-go-round, and you're turning it into this fucking fantastic bullshit about inertial reference frames and mass and matter and all this nonsense, bro, because you have to make it complicated.
Nope.
Well, right the hand, when you want to get into the details of reality, reality is complicated. Yep. So we need complicated concepts to talk about reality in detail.
It's simple. Merry-go-round goes around, you're on the merry-go-round, you're moving with it, you jump off, you're not. That's simple. You don't need to make it any more complex.
That was simple, but that's not all the details that are in that situation.
Yeah, it is.
Why do we see the apparent deviation? You explain.
You have a job.
There is no, when you say, why do you see the apparent deviation? It's easy, because the person who's viewing the object's moving. It's so easy. Come on, you don't need to turn into an inertial. If you're moving and you view something, it's going to influence how you view it.
You do agree.
You don't need inertial reference mass.
So that's good.
This is easy stuff to explain with normal words. You make it a muddy salad so that you can try and confuse people.
Why do you see it deviate?
You lied, Zanuck.
Because you're moving.
For a while and not
it's not just because you're moving.
I lied, man.
It was 2 minutes. It was 2 minutes.
You couldn't hold back, could you?
I want like a toddler.
No, he's addicted.
He wants to get out of his chair.
This is like crack.
Could not hold back.
You gotta like strap him in so that he doesn't leave the naughty chair. Did Betty kick you out, Zanuck? Did Quantum Racer tell you to get lost?
What's that? Why I'm here?
Why aren't you over there? Yeah.
I'm always there.
I know, but you're here now.
Here is more fun. I like being around the more intelligent. Party Pants and Jeremy and Sin Cleanser drive me crazy. I have to take a break.
I'm just saying, if I was trying to explain this to somebody, like if I was trying to explain it to a child or even an adult, I would just keep it all simple. I'd be like, look, man, there's a person on a merry-go-round. Both the person and the merry-go-round are moving. So any motion or anything they view will be affected by that motion. When you get off, it will stop affecting it.
But why? Why does my motion affect what I view?
But why? You can't use your brain to figure out why when you're moving it's going to affect how you view a moving object.
Though?
Come on, you're being stupid right now. Okay,
just answer the question. Why?
Right, the hand.
Why does my movement affect
why does a rock fall? But why?
Yeah, why?
What dumb idiot says, but why?
Hey, right to hand. I got a question for you. When you're talking to children, like what you just said, do you think they need to know about inertial versus non-inertial reference frames, or can you?
There's no such thing as inertial or non-inertial. That's a bullshit word. That's a word salad that you made up to describe.
That isn't the question he asked you, though. That isn't the question he asked you.
Okay, well, I'm explaining.
Clearly,
you're making.
Well, what your thoughts are on it are not relevant to this question.
Yeah, well, when you ask me the question...
but the question is about whether we should teach this to children or not, isn't it? It's about...
And I'm explaining why you shouldn't.
You don't need to. You don't need to give us your opinion on it. The fact is, it is taught to children, and how would you go about it is the question, right?
And I'm answering it. I think the term
you're just saying I wouldn't do it because it's not a real thing. And here are my reasons why it's not a real thing that you guys have just spent the last hour hearing, but you definitely need to hear again. That's what you do.
Now you're interrupting, Jim. So,
yes, I am, because I don't want to hear this again.
No, he asked me a question why I wouldn't teach that. So
so
if you don't want me to hear it,
he didn't ask you that. He didn't ask you why you wouldn't teach it, did he? He's asked you how you would go about teaching it.
I would go about just saying I would say this whether it's a child or whether it's an adult, because it's the same concept, and a child can understand this. If you're on a moving object, you're moving with the object. If you're not on a moving object, you're not. It's very simple. It's very easy. You have motion, and then you have objects. Know that. We don't need to create, but we don't need. Hold on. You're creating inertial and non-inertial when we don't need that. All you need is object and motion, which we already have. So let's just use what we already have instead of creating new stuff so that it can be more confusing.
Has to be accelerating or turning. Let me make a quick correction there.
Yeah, we have those words. So we can say that the object you're on is moving or it's accelerating. We don't need to create new words like inertial reference frame. You're making it more confusing when you create new words for things that we already have words for.
It has to be accelerating. Do you understand the difference between motion and acceleration?
Okay, but do you understand that we already have the word accelerating, so we don't need to create a new word of inertial reference frame?
Fine.
Hold on,
new words
hang on,
when you
guys.
don't-
Hang on, just a sec. Hang on, I just need to interrupt this to say, please subscribe to the channel, Debate Flat Earth and More. There's loads of mad flat Earth people like this on my channel every week. So subscribe now, Debate Flat Earth and More. Thank you very much. Back to the conversation.
So, right the hand. I understand that we have terms like acceleration, and we use the Newton's first and second law, and we understand Newton's first and second law. So when you have people that are like driving a car or on a train or any kind of object that's moving, and then people that aren't viewing it from like a sidewalk or the road or anything like that, the apparent motion that you see or don't see can be attributed to inertial reference frames or non-inertial reference frames. If we don't have that terminology, then we would have to make it up because we see something that doesn't comport with how we think we should see things.
Don't think that's why we do it, but
Zanuck knows you can leave reference frames. That's why he keeps using words like change and transform. He doesn't want to say leave. I don't know why.
You can't, because you can't leave the reference frame.
No.
Curve. I love you, Bubba.
The 17,000th time I'll get through it.
Just go back to right the hand's great example of the entire universe being one big point coordinate system. Just stay there and think about little local instances of things happening. Maybe that'll be easier to understand. If you really think of it in those terms, it might be easier.
He can't.
I don't see the big deal. I don't understand why acceleration, because it's mainly just acceleration, right? That changes your initial reference frame to be a non-inertial. I don't understand why that's such a hard concept.
Right the hand. Do you know when you're turning that you're also accelerating? You still there? You took off.
I guess to be more specific, decelerating also causes it, but.
Bro, to me, there's just motion. You have motion. You're either moving or you're not. Now, you can quantify that motion into speed, velocity, acceleration, all that stuff. But to me, that's why I make it simple. You have moving and non-moving. So you're either on a moving object or you're not on a moving object. That makes it very simple. Now, you're going to go complicated.
Let's consider that there might be a universal reference frame like you're talking about. How would we know what it is?
Well, that's kind of why I asked you right the hand.
It's
how
space,
you
bro. It's the space we move.
Hold on.
Hang on.
Are there forces?
Wait,
Danik,
stop it. Danik, stop it. Right the hand. You seem to adopt the child's point of view on motion. Things are either moving or not moving, which is why I asked you that initial question. Why do you take issue with there being a more technical and more accurate understanding of how acceleration and motion works? Why is that not okay in your view?
Because it's wrong. It's not more technical. It's just wrong. Because what you're going to say is that when you create motion not based on the motion of the object, but by the viewer's relativeness to it. So if you had an object and the observer both moving, but they couldn't see that there was motion, in your world, you're like, they're not moving. And I'm like, you're retarded. They're moving. Because when you move, it means to move through the universal reference frame that we have all motion taking place in. So this is why I think when you start teaching this stuff about compartmentalizing these reference frames that you can move through and then motion is relative, you're one wrong, because motion is not relative, motion is the object moving, and you're making it more confusing.
Are there any?
Because you're wrong.
We don't have access to a universal reference frame, even if it exists.
Hang on, I'm talking with right hand. Just give me a moment here. So
sorry, I didn't hear you.
I understand that point, but when you're explaining it and you're trying to come up with reasons for, like, if you're in a car and you know the light turns green or whatever, and you hit the gas and you start moving, there's nothing other than this fictitious force that you feel, the inertia, you being pushed back, maybe you have stuff hanging from your rearview mirror or whatever. There's nothing else other than the acceleration that causes this force to happen. So just saying moving makes it happen isn't exact. It isn't as accurate as saying acceleration is what causes.
You're being inaccurate when you start using force, because force is a concept to describe a physical push or a pull. So what you're doing is using these vague conceptual words to describe moving an object. That's all you're doing. You're making it more complicated than it is by bringing in these conceptual things.
Vague.
I say object.
It's very well defined.
Yeah, it is. No, force is not very well defined. That's why force is not very well defined. It's a conceptual term to describe physical push or pulls. So it's not a very well defined word, so don't say that it is.
And not, it is a big term than a force.
You can have that. It's fine. Your terminology for force and whatever, it doesn't matter. I was being specific about the forces that were in play, and we do have specific terminology for that, and we notice it happen. It's why Newton's first and second laws are there and why they're laws. So saying they're just not true doesn't make sense, and it's just you being disingenuous with the fact that
let me explain why. I'll explain why it's not true. Because when you hold on, let me explain.
Other than the definitions are wrong, or that forces don't exist, because we experience this and we see it happen every day.
All right. So you don't experience a force because a force is, by definition, a conceptual word to describe a push or a pull. So when you're in your car and you hit the gas, you don't experience a force. You experience the seat, the engine pushing and pulling your body. I'm being more specific. You're being vague. I was just way more specific about what happens in a car than you were.
Except you left out the part that there's a force acting on you to make it happen.
No, a force is a concept, so it cannot act. There was a physical push by the engine and the seat. You're being vague and obtuse. I'm being simplistic and clear.
So you don't believe in inertia is basically what you're saying.
Oh, we just talked about how force isn't, and then he just goes to inertia. Do you have a brain dysfunction?
Would you like to add harm, or would you like to answer the question?
Well, you just switched from force to inertia, so maybe you don't understand words. Do you think inertia and force are the same?
That would be an excellent question for you to ask yourself. Maybe you should look it up.
Well, I'm the one that's saying force is a concept. Maybe you should look this up. Maybe inertia is a concept too to describe matter and motion.
Well,
maybe you're out of your...
I took physics and I learned that inertia is a force.
Okay, well, a force is a conceptual word to describe a physical push or a pull. So which one would inertia be? A physical push or a physical pull? This is why the definition of words are very important. This is why people
is a verbal description that is a vague definer for an action that occurs in reality. You can break this down even further back.
And this is where I go. So tell me in reality what's happening when you push the pedal and the gas on the car. Don't just say a force.
I had to create a concept to communicate it to you. So this whole idea that it's just a concept isn't something that you can run with.
I was talking with
You don't have to create a concept.
First off,
you don't have to create a concept. Hold on, let me just say this. Let me say this. You don't have to create a concept because you have the physical car, the seat, the engine, all these things that you can use to describe how they are pushing and pulling your body. You don't need to create this force concept. You did, or you didn't.
If I need to communicate it, then yes, I absolutely have to.
No, all you have to say is the car is pushing you. You have to say the car is pushing you, not a force is acting on your body.
That would be me communicating a set of concepts to you. To say that the concept is just to say that a force is a word, which is a concept that we have used to describe a situation.
Okay, but
now, if you want to stop playing this game and actually get into the idea, then you can do that. Right now, you're just literally trying to say that our words are concepts and your words are real.
No,
that's not how
what I said. That's not what I said. I said force is a concept. Now, the car and the seat that you're sitting in, yes, all words, quote unquote, are conceptual, but certain words are representative of a real world physical object and real world physical things that happen. So when you get in a car, yes, C-A-R is a word, but it is a word we use to describe metal that is surrounded wheels in an engine. Now, that is a physical thing.
So you're telling me a bunch of concepts. You're telling me a bunch of concepts that make up the concept that you talked about.
No, I'm telling you about physical objects in reality, which are not concepts.
You're using concepts to describe. You're using concepts to describe something that has physicality.
I'm using words to describe things that have physicality because that's how we communicate with language. If you're not capable of communicating with language, then why are you here?
See, here's the problem with what it is. Once again, it goes back to what I said earlier. You are trying to put it out there that your words are acceptable, but our words are not acceptable because you don't agree with them. You don't agree with the base idea of using our concepts versus your own. This is not you having an honest conversation. This is you trying to say that you can run it because you have the right words.
No, all I'm saying is we can have a talk about the words. If you're going to say there's a force acting on your body when you're in a car, I'm going to say, what do you mean by force? Because your definition, this is yours, not mine, your definition of force is a physical push or a pull, or a conceptual idea to describe a push or a pull. So I'm using your words. This is you. I'm trying to understand
No, a
what
force
you're
is actually
saying.
any interaction that causes an object or something that is physical to move or have an interaction. Now, if you want to break down, once again, you just strawmanned something in there so that you could try to come away with saying, because I'm using something that is the root form of what is in a force, then I'm more correct than you. Stop playing these silly word games. You're not going to win.
Okay, so it's not about being correct. It's about who is more accurate in the description of reality. Now, when you said there's a force acting on your body, you're very vague. People don't know what you're talking about. But if I said a person is sitting in a car and he pushes the accelerator with his foot and the gasoline and what's not goes into the intake and the car then pushes him forward, they're going to have a clear understanding of what I'm talking about. So you're using vague conceptual terms to try and describe something and then saying that you're more technical and more accurate when you're not.
Right. That's
They're
not
only going to
accurate.
understand that if they have the same concepts for all the words you used. If someone has the concept for the words he used, they're still going to understand.
Right the hand.
That's why we clearly define the words before we use them, which is what I'm trying to do with force.
Yes.
Force is clearly defined. It's a category, so it's not as specific,
it's clearly
but it's
defined
still clearly
as a concept. It's clearly defined as a concept, not something that can move an object.
No. Stop being silly.
All right. Maybe my voice.
So just shake your head and go, no.
But right the hand, you're describing situations, which, sure, you can describe a situation just fine. But when you say we use a force and it's not as descriptive as you describing something, that's not true. We say inertia is the force. And inertia is well understood through Newton's laws. And unless you don't think Newton's laws hold true, then you have to either accept that what we're saying is accurate or more accurate than just you describing a situation. Or you have to refute Newton's laws, in which case we can stop right here because you would be the only person.
Because, okay, so let me respond. Basically, you said the exact same thing. You just said the exact same thing that we just said before. You're just describing what happens, man. You didn't bring anything new. A force is a concept, bro. Here, let me say, when you said inertia.
Push is a concept.
Okay, when you say inertia, you're not describing, if I said I experienced inertia, that would be just as vague as saying a body experienced force. Now, if I said I was pushed when somebody, hold on, if I were to say that somebody pushed me, that would be descriptive. When you said I experienced inertia,
what does
that's
it mean
vague
to push?
And conceptual. To have a physical interaction from matter to matter.
Right. And you
what does it mean to have that interaction?
It means that physical matter, physical matter that is moving.
Push. What's the unit
let me
measure?
go with this.
The unit measure.
Let me drill this down. What does it mean to push on? We're at the hand.
I like the unit measure of the push.
Somebody's at my door. I'll be right back.
Just a minute.
Zanuck, you know that question killed this whole argument.
When you dig down to what pushing on something means, it means that the electromagnetic force between the atoms of the object applied a force to the electrons of the other atom.
Hang on, man. He's at his door. He's not here.
I know. I'm just saying that's where I'm going with it.
And then what units of measure are we using for that push or pull or force or attraction or repulsion?
Well, I think it would be good to go down this line of questioning, not so much to explain to him your side of it, but to get him to articulate his side of it. Because he does this a lot where he gets away with making a lot of assertions and people will interject and say, no, that's wrong. But nobody ever actually has the exchange of, okay, well, why do you think that?
This whole leaving reference frame thing.
Yeah, we dug down to what science is last night, and he actually agreed with everything that science is. He just used different words.
Yeah, like right now he is straight up refuting Newton's laws, and we all know that that's not what he actually thinks. He's just...
And Lewis, it's a shame you missed my little exchange with him the other night where I got him to explain to us what he thinks light is and started going into Freud knot theory or something. It's his idea of string theory, and it's amazing.
No, I'm really sad I missed that.
Can we get a cliff note on what he thinks light?
Well, you have these little strings, and where they cross, that's what we call, like, the atoms. And they, like, vibrate due to energy, and that's light.
What?
That's about all I can remember. There's really anybody remember? Did anybody hear it? Anybody remember anything to add to it?
Sounds like he's made up his own version of string theory. Or,
Pretty
well,
bad.
there are many versions of string theory, but it looks like he's made up his own version of string theory.
Yeah, he said something about the strings start waving, and when they wave is when they produce light. So that's what a light wave is. Yeah. I don't know. It was the weirdest idea, man.
So if someone asked Right the Hand to create a simple free body diagram for what he's trying to explain, the diagram if he were able to construct it, it would show the same quote interactions that he's saying as a regular free body diagram would show with force vectors. Correct? Is that it would show the same vectors? He just calls them interactions, where we understand their forces.
Yeah, because when you get down to the actual mathematical definitions and descriptions, that's what's needed to actually do the calculations.
Yeah. Okay. So his issue is just words.
But he's never.
Okay.
Sorry. So he's never gone that far. He's just at the word salad stage.
Okay. So he can't get past the word salad, basically.
I actually had the thought of bringing in like yaw, pitch, and roll of an aircraft and the thrust vectors and the body frame, and then
but even just a simple, like the most simple free body diagram, like a cube sliding down a ramp. You know, that's like one of the that's physics 101. That's like university physics 1. You know, it's like extremely. If you can't get past that, then there's like if you can't comprehend that, there's pretty much no hope, right?
That's not even university. One, that's ninth grade science, physical science.
Yeah,
or just even a ball rolling down a ramp. Like that's something
I mean,
you
you get introduced to it in high school, but I mean, in my first semester of physics class in university, it was sort of review, but we still went through those like chapters, you know.
Because even though those are simple exams, now you actually add a little more succinct terms like, you know, what is the frictional force on it, is the normal force, blah blah blah, all of that.
There's a lot of assume spherical cal, you know, in like first semester physics.
Assume the chicken is a sphere. Yeah, I know.
Yeah.
Just so we're all clear, we ended the debate on if you can leave reference frames or not. We now
Jeremy,
know you can leave
just
reference
stop.
frames.
Just stop.
No, we know you can. Xanax said you change them.
No.
I explained it.
No, there's no leaving it. Jeremy.
I explained it in my maybe.
Can you take Jeremy? Do you agree with what I said? You can take a video of the ball.
Yes.
From both places.
Yes.
Well, you never let because.
But listen to my. Did you hear my
reference frame is the ability to measure the position in that frame.
Did you hear my example?
I heard Jeremy. I did hear you. I'm not trying to like dismiss it, but I heard you. So you don't need to. All I'm saying is that I explained it in a couple of different ways over many different times. One is that if you have a camera in both positions. Two, if you imagine there's a laser from that position to the ball, it tracks it automatically, right? Because that's the position vector as well. Like you have to. There is no mathematically. There's no leaving the frame. I know you're conceptualizing that way, but when we talk about in terms of physics and dynamics terms, it's not left the frame because I can write it in both. I can write the position, velocity, and acceleration in both frames.
Mathematically, whatever. I'm talking about reality.
No, that is reality.
Mathematics is the representation of reality.
Math reality. Come on.
In this instance, it's not because you're leaving the reference frame.
No,
God. Reference frames aren't a piece of reality. They're a piece of how we describe reality.
Yeah. Hey, Jeremy, if I asked you, is there any point in time where you would either not experience Newton's first or second law, what would you say?
Well, Newton falls apart when you get to the interstellar.
Look, we're not talking about that. Don't obfuscate. Come on. He has to get
the quantum.
Question. Don't.
Come on. Answer the question.
What was the question?
Do you ever in a situation where you don't experience Newton's law to be true?
Don't. I don't know. Maybe I don't know.
Do we want somebody want to do a summary of what they are? Because I don't think Jeremy has a grasp of what the first two laws.
When you're on this non-inertial reference frame, Newton law is really that bulk's deviating like that.
Jeremy, can you recite Newton's laws? Just out of curiosity.
Not right now. I'm eating dinner. I really
Okay,
shouldn't be doing
the first law, Jeremy. The first law is
An object
is
in
an
motion
object
will stay in motion unless it acted upon by another force. Blah blah blah. Bro, you're
by an
just
outside
talking
force.
bullshit. Force is a concept. We just established that force is a concept
No,
word. So how the hell?
you think that it's a concept?
This
Okay,
Google.
that's
I'll
the
tell you
word.
what. Okay, I'll tell you
Can
what.
we have our
Google
conversation
is
have a
force a
conversation with
concept.
Jeremy, man. You sit down for a second.
All right, man.
Let's
Well,
have
just Google if force is a
conversation,
concept.
Jeremy, without Artie's interjection.
No.
And
Let,
then
let
How
once
many
we
right,
pounds
Jeremy,
per square
we can
inch of
continue.
concept could be applied to your skull with a baseball bat?
Yeah,
let
exactly.
right
You can
the hand
only
go ahead.
apply
I
the
gotta-
bat.
Let right the hand go ahead. I'm cooking.
What?
You know, for what it's worth, I'm willing to say it right there. Yes, force is a conceptualization that we describe mathematically, so
Thank
that
you.
we can actually do some calculations. If you want that, go ahead.
Well, but
But it
then
doesn't change Newton's
it
first,
does.
second, and third laws.
It does,
No,
because
it
then a
doesn't.
force is not acting. You can't have a concept acting on something, so you have to reword your damn fucking law.
This is the same, dude.
so
This
what
is the
you
same
would
word
do-
salad that Slick plays with.
You
Math
just-
only being a
hold on.
something. It's just word salad. You're just
All
playing
I'm
word
gonna say,
games.
all I'm gonna say is, you just got done saying that it's a concept, and then you're gonna say that it can affect
I
something.
accept that it's a concept. I accept
then
the concept because it was defined to be that way. So
Okay.
if you want to say that it's conceptualized and then defined, fine. I'm happy with that.
If you look up
But
the
it
definition
works.
of force,
But no, I'm asking you, can a concept affect a moving object?
And
Yes or
this
no?
is the
Force
word
is
salad
not a
part that you
concept.
play.
Force is
Sorry,
not a
I
concept.
mean,
If you look it up, like you just suggested, you find the simple definition of force is a push or a pull on an object, but it does not.
Okay, so then change new.
It does
so then
not introduce the word concept anywhere in that definition, and it
It's-
is the simple definition of force. The more
Okay,
complex definition of force explains it even deeper, and there's no way in any of those definitions is it expressed as a concept.
Okay, so I'm reading right now. Or tell me if I'm wrong. If that Google is not saying this. Force is the fundamental concept in dynamics, and before we can move forward to understand Newton's laws, we have to have a clear definition of this concept. Okay, so this is right from Google. Is force a concept? So you're saying Google's wrong. It doesn't say that force is a concept, right? And I'm just a retard. I'm just not understanding the words that are clearly right in front of my face. But you're going to keep saying that it's, well, but this concept can affect things. It doesn't change it. It changes everything, because if a concept can't affect matter.
In science,
understanding
push
is
and
that
pull
a concept when it
matter
comes to
causes it to
physics,
change
the concept
velocity
of
to
force.
accelerate. Force represents its effector, which means it is both magnitude and direction. No, this is from thoughtco.com, chemistry, physical.
There has to be objects there.
Ahead.
Force is the conceptual word to describe it.
Why don't you post what you're reading?
Okay, I don't need other people to define the words that I use.
Yes,
I can use my own brain. No, I don't. I can use my own. If you can't define the words yourself, then
you need things. You need people to define things for you.
No, I don't. I do not. We have a set of
You need to understand when you are wrong, and just repetition and talking over people is not going to make what's wrong right.
You're right. It's next.
It's fine to define things for yourself, but if you're going to talk with other people, it's a lot easier if you use the same definitions that they do.
Well,
Right
and
ahead.
understand the definitions.
Where are
I'm
you
trying to
getting this from? Because I'm looking at Google, and the first 5 definitions that I've seen, the word concept is not.
So
mentioned.
here's the difference.
Where are you getting this?
Here's the difference, rocket scientist. He's searching, is force a concept? Those 4 words
Okay,
together.
yeah. Okay, so the keyword, it'll definitely find.
Exactly, exactly. So the Google algorithm will,
Looking
of course,
definition
give him
of
that.
force.
Yeah.
Okay, so but here, so is it wrong? Is it wrong though that force is the fundamental concept of dynamics? Is that wrong?
Why
Is
not?
Google wrong?
But
Why
I'm not
I'm just asking if it's wrong. Are you just tell me if it's wrong so then I can
When the
find.
others disagree with it.
Okay, so which
Why
one's
go with
right?
that one? It's out.
Okay,
it's
so
outnumbered.
Okay, so let me just ask you a question. Let me ask you a question.
Majority wins.
Okay.
No, we're throwing it out because it's the weakest one. It's the lowest numbers.
Okay, so I'm going to ask you something. If I were to kick a ball, did I move that ball with the motion of my foot or with a force?
Yes.
You applied a force to the ball.
Okay, no, I was.
How did you move your foot? How did your foot and leg move?
Okay, so first let me ask you
No,
a
you're
question
not
about force, and we're understanding force.
You're on a
'Cause I'm not going
losing.
to say that.
You're on a
No,
losing.
okay,
pitch
bro,
here.
come on, man,
So,
come on, be adult.
no, don't pro
Okay,
me.
now
No.
it's triggered. Now it's triggered.
No,
It has
it's
to go
not
off.
triggered.
Get it out.
No,
Let
it's
me know
not
when
triggered. Yeah, get it out. Get it. Here we go again. Say you've gone to the divert script now.
I
So you
know,
put
I
your
know.
little
Do
piece
your
of paper
thing.
down.
Do your
Yeah,
thing.
I know. Yeah, that's the next line on the script. Same as you do every night when people insist that you back up what you say, think about what you say, tell you you're wrong what you're saying, try to correct what you're saying is wrong. You imparted force into the ball when you kicked it.
Okay, but we just understand that force is a concept to describe a physical push or a pull. Okay,
Just a concept. Force
okay,
is not
okay.
a concept.
So now let me ask you a question. Okay, let me
Cannot
ask you a
find
question.
a number of definitions of force that say it's a concept.
Okay, so let me ask you something. In Star Wars, they moved objects with the force,
It's
right?
a science fiction movie and it's got no relevance to reality whatsoever. Stick to the real world. You, goddamn, you go on about reality and
Why are you
concepts.
so triggered? Why are you so triggered?
You go
Look
to
at this guy
Star
being triggered. Wow. Okay.
What's going to be next?
I'm
Matrix.
asking
You're being ridiculous.
Well,
Are you
I'm
going to be?
just trying to. I'm
Are you
just trying to have a
Neo?
conversation.
Are you going to say you're
I'm
going
just trying to have a conversation.
No, you're not.
Next?
Don't lie.
Okay.
You're not having a
Try
conversation.
and let him get it out though, Bizarre, because
It's the same shit.
I know, but that doesn't give you the right to just shout him down for 10 minutes. Please, just let him get it out.
No, you fucking ban and mute me then.
No, it makes
If
for
I
poor
have to do that, I will. I was trying not to do that.
Come on, I'm fucking sick of you, Jem. Piss off.
All right, fair enough.
So,
I mean,
let
me just make my point. The point I'm trying to make is that in Star Wars, when they moved something with the Force, they didn't have any way in which it moved. It was just this magical force, right? So if you were going to say, when you moved a ball, you used force, I'm going to be like, you're talking about a science fiction way of moving an object. I need a real world mechanical explanation.
Is this really your argument?
If you want specifics, you use the electromagnetic force.
Okay, but you're still using the word force and electromagnetic. I'm not getting a clear understanding of the.
Put those two together. Put those two together, and you have a specific thing.
Okay,
Yeah,
but no electro. Okay,
have a talk with us.
Let me.
RTAs. You have. Hang on. No, let me get.
No, I don't have to do anything. Please don't tell me what I have to do.
RTAs. Listen. In a conversation, you have one person talking, then another. You keep saying forces are concepts. Everyone here.
No, I moved on. I moved away from that. I'm moving away from
this book, or used any kind of reference material that talks about forces. Will tell you that a force is the push or pull, like you said, on an object, resulting in an interaction with another object. So that is what a force is. You can ditch your concept thing entirely because we all understand really well what a force is.
Okay, but when you say the word force, what you're talking about is the physical push or pull. So the force, when you say the force, that's not the mechanical means of motion. The force doesn't move the object. It's the physical contact of a physical object moving and creating that contact that moves another object. So when you just keep saying
there is no physical contact. There is no physical contact. There's only electromagnetic forces.
Okay, hold on. Now this is where I'm going to. Now this is where we get to this point. Now, when you tell me that there is no physical contact, I'm going to say, so when a magnet. Hold on. When let me just get this out, and then you can address. So when a magnet at a junkyard lifts a 2-ton car, you're going to say there's no physical connection between that magnet and that car, and it's just the Star Wars force.
No, that's not what I'm saying.
Okay, so then
when most people think of physical contact, the naive idea is that things are actually touching each other.
Okay, so let's clearly define.
Accurate. Let me finish. I'm trying to clearly define. What most people think, the naive idea of physically touching is not actually what's happening. There's not actual things coming into direct contact, like occupying adjacent spaces. There's only things getting close enough that they have a repulsion to each other due to the electromagnetic force of the electrons around the atoms.
Okay, so what you're going to say is, I'm holding my phone right now. So now, I can feel the phone in my hand. Now, can you quantify that? Hold on. Can you quantify that I'm not touching this phone physically, but there's this invisible barrier this magical force field that is supporting the phone in my hand. Can you quantify that in any capacity?
Yeah, that's the electromagnetic force. I don't have the specific numbers to quantify it like I think you're asking for.
I'm not asking for numbers. Like in reality, I feel this thing on my hand.
That's usually what people
right?
mean when they say quantify, but okay.
Well, because here's the thing. I'm saying I can touch, like if I go over to something and I touch it, right? When we think of touching, we think of physical contact from my hand, which has matter, to touching the thing. Now you're going to say, no, that doesn't happen. There's actually this invisible, this force field that stops it. I'm going to be like, yo, quantify, show me that, because that's just, to me, that just sounds like a belief.
That's what I'm trying to say. It's a little bit more complicated than that. It's not that something stops you from touching it. It's that touching is a little bit more complicated than the naive idea of it.
Well, maybe it isn't, and you're just making it more complicated because you have a belief.
You got your contact forces. So, if you touch something, or if there's friction applied or tension applied, if there's air resistance from objects falling, there are all these
at a
contact
distance
forces between objects.
Now we have the at a distance force.
There are distance forces, which are your gravitational and your magnetics, like with your magnet example. So there are
Let me ask you something. Why don't they call it non-contact?
They're not all the same.
Why do they have contact and at a distance? Why don't they have contact and non-contact? Do you know why? Because non-contact sounds fucking stupid, and nobody would be like, how do you move something without touching it? So they put this euphemism at a distance, so you think that the action or the mechanism is over there, right? You're still not explaining.
Well, because most of the time we don't have to concern ourselves with the subatomic forces.
Okay, but you're just saying subatomic forces because in my world, you have no idea. Hold on. Because in my world, you have no idea how a magnet actually makes this car move. Like, you're like, well, we have these atoms that are bouncing around, but that can't explain. Okay, and I'm saying that your entire idea of how it is impossible with an atom. Like, a bouncing atom, you can't lift a car. Like, unless these atoms are bouncing from the bottom of the earth to push it up. Well, then explain. Can you just explain to me how atoms or photons or whatever are lifting this car? Explain that physical process.
Yeah, you can do demonstrations. You didn't do this in like college. Like, you can take a graphene, put it on a paper, and see the electromagnetic forces from a magnet. Like, we can see real world examples of
putting iron shavings around a magnet and seeing the iron shavings take this form doesn't prove that there's this mystical. Maybe it's a physical connection that you can't see. What about that?
Oh, it's still physical. It's just not matter.
Okay, well, so now I'm going to say, how can you be physical without matter? Isn't that the same thing?
Because matter isn't the only thing that's physical.
But, okay, so when you say physical, don't we mean to have some sort of matter that occupies space to exist in reality? Nope. Isn't that what you're talking about? Okay, so how do you define physical?
Part of the physical world.
Tell me how you define physical then, because I just gave you my definition. So
right the hand. What was the point you were trying to make in this initial diatribe?
I just want to hear his.
No, I just want to be clear because I lost track.
Okay, because you're saying that you have things that are non-physical. So now I'm getting to how do you?
I didn't say they're non-physical.
Okay, well I'm saying I don't know what you mean when you say physical, right? Because now like, can you? I defined physical, and you said no. So I was like, okay, so what about it was wrong? And
as an adjective.
You can't stay on point. Seriously, it's just
we're talking about forces, and he's using it as an adjective to describe forces that are
right. Okay, thank you. That's what it was.
Or ones that are done without physical touch, like gravitation, like magnetics, like electrical forces.
Yeah, well, I'm saying maybe it's a physical touch we don't understand.
And the fact that you don't agree with that is fine. You can have your beliefs, but when you're having a conversation, you use terminology that both people understand, and that is an understood terminology.
Okay, yeah, but I disagree with the fact that you can move or influence an object without touching it. And you're going to say, I know. And
you're not the one who was doing calculations with it.
Hold on. Let me just get this out.
So your understanding or lack of understanding doesn't really matter.
Okay, but here, let me say it. When you say math, right? So if we were at the junkyard and we watched this magnet lift a car, math would never explain how that works, right? You could never give me the math.
You would describe it.
I could see it moving forward, right? I see it. I don't need math to describe it. You need to use words to describe how that's happening, and you can't do that with math. So can you use words to describe how the magnet lifts it up?
We can use words to do math.
Great, but can you use any of those words to describe how the magnet is lifting a car?
I can look up the mathematical equation for magnetic forces and how they work.
We just got done establishing that the equations are not going to tell me how it's happening. I want to know how how this magnet is lifting a car. I don't want to quantify the effects
Well,
that
too
I have in
bad.
a...
We can drill
Okay, so
down
you
a
have no
few
idea.
explanations. No, let me finish. We can drill down a few series of explanations that gets at part of the how, but there's always a root how for nature that we don't have the actual explanation for.
Okay,
And that's okay,
I think,
as far as I'm concerned.
but you're telling me that it's a non-physical mechanism. So I'm
No,
like,
I'm not.
I can't even
No, I'm not.
fathom.
You keep getting that mixed up.
Okay, hold on. So I'm saying, you're saying it's a physical connection that has no sort of matter, and I'm like, I can't comprehend being physical without being matter, right? Because everything is made of matter. So if you don't have something that's made of matter, you don't have anything to exist. Okay, so what exists?
Light is not matter.
And now, okay, and so now I want to ask you, how can
Electromagnetic fields in general are not matter.
Oh, but you're just saying this stuff. Like now, so what we're saying is everything we can observe and the and how things work is they're made of matter. But then we have light, and you're going, well, light's not made of matter, but it still exists. I'm like, how can God be not made of matter and still exist? Can angels be not made of matter and still exist? Is light the only thing that can be made of matter and not still exist?
Well, those things are supernatural, so they're not part of.
Well, maybe light is supernatural.
Scientifically, anyway.
Maybe light is supernatural.
Well, we can study. No, by definition, it's not, because it's part of the physical world that we can interact with.
You don't interact with light.
Of course I do. That's how I see things.
No, you see matter, right? You see a tree. You don't see light.
Well, that matter reflects or emits light that travels through the space between it and me.
Your belief.
It hits my eye, and that's how it works.
And that's where. And no, you think there's this thing with no matter, with a massless particle, even though particle is defined as a small portion of matter. You think there's a massless particle bouncing around that makes you see?
Let's stop that.
Yeah.
Bro, even in the fucking physics definition,
No.
even in the physics definition, it's a physical object that has magnitude, vector, and blah, blah, blah. So it all use physical objects.
One
this is the whole idea.
definition.
Okay, but this is why we need a clear. This is why you need
to a topic
because you need a clear.
You guys think this is easier than reference frames? You guys think this is easier topic than reference frames? Are you freaking kidding me?
No, but that's where it went.
Oh my God! This is
all
way
I'm trying
hard.
to say.
I don't even know where to
All I'm
start
trying
with
to say.
right
One thing, we're not talking to Jeremy anymore.
All I'm saying, look, I'm just trying to say,
in order to
explain how something happens, make me see the process in my head. If I'm going to tell you that I threw a ball and we're like, I grabbed the ball with my hand, I wrap my. So when you use a magnet and you're just saying electromagnetic force, I can't understand how it's working. When you say non-physical connection,
your teacher.
I've taken a physics class, and these are the questions I've been left with.
We can't fix you.
I've
Did you
taken
ever ask
many
your teacher
classes.
about
Yes, I did. He just
field?
stopped
What a
responding.
field is?
He just deflected like you guys did. This is what
Is there a
they have
brain
no answers.
surgery in the house?
They have no answers.
I got an unfortunate news for you, RTH.
He can't even define physical.
And physics aren't for you, buddy. If you can't,
maybe it's not for you.
No, maybe it's not for you. I had people I taught
I don't have these
that were chocolate.
Bro, you
bars
just
filled
have
with
people that
better
repeat what
shit.
you say. Nobody questions what you say like I do. You can't even describe. You can't even clearly define physical right now. You can't even do that. Because you rely on a photon being physical but non-physical, affecting physical things but being non-physical. So you will never clearly define physical.
You read it.
So they clearly define physical right now.
Definition.
Bro, we need to before we can start saying what a photon or what angels are.
The interactions of things in the natural world is physical.
Okay, well, things. So you have to be a thing, right? You got to be a thing, a physical thing to interact in the real world.
Made of matter.
No, not a physical thing. Things are physical.
Is feelings? Is love a non-physical thing? Can love affect a rock fall?
Actually, love can affect a lot of physical things, like chemicals in your brain.
No, that's the chemical reactions you describe conceptually as love. The only thing in
Do you really want to go down the philosophical rabbit hole that you just opened?
Bro, this is because you're trying to establish your entire basis of light on this philosophical rabbit hole, my man.
All right. Let's go down this physical rabbit hole. Are you a materialist, a dualist, or a something else?
You have to. What is material?
Satan.
Squirm your way back to your same old narrative, which is about massless photons. We weren't
It's a
talking about
stupid
that. We
idea.
were talking
You
about
it is.
an
That's what
reference
electromagnetic
frame.
field is.
You ran
An
away from inertial
electromagnetic
reference
field is a
frames because
massless
you
photon.
don't understand inertia. You don't believe Newton's laws. You apparently
Now he
took
has
a
to
physics
deflect from the
class and didn't
conversation.
pass it. You have these questions, but instead of
Now he's got to
finding the
talk
answer,
about me.
you think you know the answers, and you're trying to educate us, but you're not educating us because we actually know physics and you don't. So you can keep crying about this.
All right. So
or
can you
can
define
shut up and
physical?
listen and learn.
Can you define physical?
You can't even.
Like I said, you want to go down. If you want to go down the philosophical route,
don't you
I
think
was
you should be able to
responding to
define
you.
physical? Can you define?
And I'm trying to respond to you.
Let me hear it, because physics is physics.
Are you? Do you want to take the materialist, dualist, or some other type of view?
Well, do you have to explain and articulate what each one of those are?
All right. For the materialist view, the physical is all there is that we have evidence of. So that's an easy definition.
Okay, I get it. So for me, I'll give you my point of view. I believe we live in this physical world, and the only thing that you can interact with are physical things. Now, is there a non-physical, a spiritual side? You know, I believe there is, but that's not based in fact because you can't touch your experience or quantify.
That would be dualism. That means that there's the physical stuff that we can interact with, and then there's the usually labeled mental or non-physical that we can't interact with.
Now, let me
Either
ask you
way,
this.
physical is everything that we can directly interact with.
Can the mental interact with the physical?
Now that's a rabbit hole.
But that's the rabbit hole of light. That light is non-physical, but it's interacting with.
No, it is
nature.
physical. No, it is by definition physical because we can interact with it.
Okay, so then light has a physical structure or body and shape.
That's not the physical definition he's talking about. It is a part of our physical world. You can interact with it by standing in front of a light and looking behind you and seeing a shadow.
He's got physical on lockdown with matter.
Yeah, this is what I've said several times. You can't argue with someone else's ideas by using your own definitions.
Well, this is why I'm trying to clearly define what these words are before we move forward.
You're doing the exact opposite. Don't lie.
Your definitions are wrong.
Why don't you make up new words?
Tell me why.
That you're
I'm not making up
already
new
have
words.
definitions.
Definitions are definitions. They're only wrong if you're trying to use them with someone else's definition.
Right.
That's different.
Make up a new word
Doesn't
or
this
find
sound
a more
simple?
accurate word.
I'm going easy. Let's keep matter. You have matter, which is stuff, and then you have non-matter, which is like thoughts and feelings. Like it's very easy. They're two things, and the non-matter can't interact with the matter.
It's easy, but
very
it's also
simple.
incomplete.
Okay, but now you have to say why it's incomplete.
What's a radio signal or a microwave?
So
is that physical or not?
I believe it has to be physical, some kind of non-physical, some
Does it
physical
matter?
non-visual. It has to be matter because only matter can interact with other matter.
Or maybe you're wrong about it having to be only matter.
Well, but I can't see anything other than if you say that you can have things that are not matter. To me, that's like an angel.
Well, you also can't see.
Maybe you're wrong.
Doesn't mean it doesn't
Well,
exist.
I mean, you know,
who's seeing?
Wouldn't an angel? An angel would be non-physical, right? An angel wouldn't have a physical body.
Seeing microwaves.
I didn't say you could. I said non-visual. Microwave is a non-visual physical interaction, like wind.
But it's not
you can't
matter.
see wind. Yeah,
It's not matter. Wind is
physical.
matter.
I think
Wind is made of
microwaves.
matter. Wind
and
is
I
moving
think,
air, which is matter.
Yes, and I think
Okay,
microwaves
so
are
drop that
matter.
road. Drop that road. Back up. Back up. Going the wrong way. Now get
but
back to talking to Slacker about things accordingly.
Yeah, and I'm saying that I believe a magnet
I
and a
used your
microwave
definitions
work.
when we talked about science yesterday. It'd be nice if you could use our definitions when we talk about this today.
But if I don't agree with the definition, why am I going to use it?
To have a conversation with another person. That's why you agree on definitions.
Well, I would think the conversation would be about an agreement on the definition of the word before we go forward. And if you're like,
that's
well,
what literally that's what every conversation with you
our
is.
definition
Word.
Do you think
It's
that
words.
maybe? Do you think that maybe it's because you guys use?
We never
a
actually
vague
get to. We never actually get to actual science with you. It's
because
literally just words.
Right there. This is where I just took your definitions yesterday when we were talking about science. I just took them, didn't argue them.
Okay,
It'd be nice if you could return the favor today.
But you took my definitions because they were.
And we all agree that
I disagreed with how good they were several times.
So
I just said, okay, we'll go with it.
blue, then come up with another word to describe the color you're actually trying to say. But we all accept blue is blue. So if you don't think blue is blue, then come up with a word or find a more descriptive, like you're actually talking about indigo.
I'm trying to clearly define. I'm not trying to describe a color which can be a little different to everybody. I'm trying to describe a physical object which everybody can touch, which should be a very simple thing. Physical object, a piece of matter that has a body and shape, right? This should be pretty easy, but it seems like it's super complicated for some reason. It's because you're trying, because you have these beliefs about life.
It's just that we have a different definition.
No, you have a different belief. You believe light. You don't want to see. You'll mock Christians for believing in the non-physical God and angels, right? And how they're interacting with the world. But then you do the exact same thing with light and a photon, and it's non-physical, but it's interacting with the world. And
No,
you
we're
expect
not
us to take you
non-physical for the 1000th time.
But okay, but you define physical as, you can't say a particle. This is why you're just a straight contradiction. You'll say photon is a massless particle when a particle is defined as a small amount of matter, and all matter has mass.
But
So if you're going to use the word particle,
that's not the only definition of particle.
okay, but use the
Adjectives
other.
are hard.
So then use the other one. Use the other one, and watch how you have to say object. Go ahead, read off the physics one, because I know that one too. I know all your fucking.
When we're talking about
bullshit,
the fundamental particles are the things.
do you know? Hold on. Do you know the other? Do you know the other definition that you were going to try and recite?
I wasn't trying to recite.
Well, if you're going to say, well, hold on. If you're going to say there's more definitions to particle, then give me it. I said particle is defined as a minute.
Let me finish. I said it depends on the context that you're using it in. When we're talking about subatomic particles, they are the building blocks of everything I can't talk. They are the building blocks of physical reality.
Bro, don't tell me what something is. We're trying to define what physical is, what matter is, and now you're telling me what things are. So particle, define particle for me if you don't like my definition of a small, minute portion of matter. If you're like, that's wrong and I'm going to use another one, then tell me the other definition.
Matter is anything, any substance, any amount of substance, any amount of matter, mass.
Yeah, if you want the drill down, there's the particles, which is, what Zanuck just said. You got your subatomic particles.
I don't want you to name particles. You're naming particles. Don't name particles.
Yes, we have
define the word particle.
The word for these. If you don't like the definitions, then come up with your own. But don't argue ours, because come with my own every day and have a full and clear understanding of them. If you don't like it, come up with another one.
You asked me my definition of particle. The word you were using, I said you can't say that a photon is a massless particle because a particle is defined as a minute portion of matter, which would then have mass. Hold on. This is the thing. If you're going to use words to describe what light is, light is. Hold on. Okay, so then give me the other. So give me. So now I'm asking.
I've got a definition for you. And if we're talking about light, we're talking about elementary particles.
Localized object.
We're talking about elementary particle. Let me finish.
Define it.
We're talking about element. I'm trying to.
Let him talk. Jesus Christ. There, he's got the right track here. Go ahead.
We're talking about light, so we're talking about elementary particles. Any of the various fundamental subatomic particles, including those that are the smallest and most basic constituents of matter, or combinations of those. And those that transmit one of the four fundamental interactions in nature.
Okay. My problem is you use particle to define particle. So I'm looking.
No, I didn't use particle to define particle.
Yes,
I used subatomic particle in the definition. Let me finish.
Define particle. Don't give me
I'm not defining particle. I am not defining particle.
I know you can't. You can't because
I didn't say can't. I said I'm not.
So then do it now, or you can't.
You
can't move forward. You can't move forward on what a particle is unless you define it.
I am defining the term elementary particle.
No, particle.
No, we are not talking about particles in general. We are talking about a very specific kind of particle.
Okay.
Elementary particles.
When you say okay, but when you say very specific kind of particle, you still never define particle. You're just going to give me an elementary
particle. Because we're
particle.
not talking about them in general.
Well, then define particle and then tell me the difference between a particle and elementary particle.
A particle in general is one of many different things depending on the context in which it is used.
Okay, so
now the context that we're using it is the context of elementary particles, and I already gave you that definition.
Okay, read off the elementary particle definition again.
Any of the basic fundamental subatomic particles, including those that are the smallest and most basic constituents of matter, or are combinations of those, and those that transmit one of the four fundamental forces in nature.
So an elementary particle is any of the subatomic particles.
Fundamental subatomic particles, as in they're not made of other particles.
Okay,
protons and neutrons are subatomic, but they're not fundamental.
Bro, we're talking about particle. So an elementary particle is any subatomic particle. Do we?
No, and I was trying to clarify that when you interrupted me. It is fundamental subatomic particles, as in ones that are not made of other particles. Protons and neutrons are subatomic particles, but they're made of other particles, so they're not fundamental.
Okay, so a fundamental particle isn't made of particles.
Correct, as far as we know.
So why do you use the term particle?
Jesus fucking Christ.
Have a better word.
Isn't made up of other particles as well. So there's not a compound particle. There's not a little bit of A and a little bit of B. They are the building block. They are the baseline. There's nothing that they break up into. Good Lord.
Okay, so it's a particle. It is a particle, but it's not a particle.
That's not what I said.
Okay, well, you said.
Why are you saying that?
Because I'm trying to understand. It seems you're saying stuff that's a little confusing. So an elementary particle is a subatomic particle, and then you can have fundamental particles that aren't particles, right?
No, an elementary particle is a fundamental subatomic particle.
And that would be a particle then. And how did you define particle?
Particle is one of various things with various definitions depending on the context and which it is.
Okay, but in this context, because you're saying a subatomic particle. Now, you're using it in a context.
Subatomic particle is a compound. Fundamental particle is a compound word. You can't just pick it apart and define part of it and the other part.
I'm asking you to define. I was asking you for the definition of particle. Then you use the word subatomic particle. So now I'm asking for the definition of subatomic.
Guys, constituent of matter. He said it already. It's a constituent of matter. That's it. Done. Move on.
Or force carriers.
Move on. Oh yeah, it could be force carriers. You're right.
Subatomic particles are particles smaller than an atom.
Okay, but they're still particles.
Nobody said they weren't.
Okay, and a particle is a small, minute portion of matter.
No, you need to drop that definition.
Well, then give me another one that doesn't have particles in it. No, you gave me one that has subatomic particle, and it.
He just said a minute portion of matter. That's the exact definition that Google gives you. So he's Googled it and played dumb this whole time.
Well, the photon.
You contract in. You contract amnesia every time that you are told another definition for particle.
You can have a, but when you. I just want to know what particle means in the context in which you're using it for subatomic and elementary.
Particle is one of many things with different definitions depending on the context in which it is used.
But so in the context you're using, please clearly define what it is. Don't just tell me that it has many definitions, because then you're just using a word with no definition.
Right, this is truly has to stop. When he says subatomic, he's giving you the goddamn context.
So what is? No, he's not defining what a particle
is. There is no more discussion on this. Your refusal to believe words which are clearly defined is your problem. Do not impose it upon others. It's dishonest.
Okay, so a particle is subatomic. So the definition of a particle is subatomic.
What about a photon?
If you're talking,
I'm not asking for particles. We still haven't defined what a particle is yet. You told me don't use a minute portion of. No,
you guys
he used particle in the definition.
I get it.
Well, I asked what a particle was, and you gave me elementary. You gave me elementary particle. You gave me fundamental particle, and you gave me subatomic particle. I never asked for different particles. I asked for the definition of particle.
A concentration of mass, did they not?
Okay, so but
that's
mass
one of the various definitions.
Okay. But is mass not a property of matter?
Only in a reference frame.
Okay, so now you're just being retarded. So what you're saying is a constituent of matter.
Like the man said, it's one of
constituents of matter. Yes.
Okay, so a particle has matter.
Subatomic particles are constituents of all matter.
No, I'm not asking for subatomic. We're defining particle right now.
Any particle.
Well, then you have to specify a context.
Okay, a subatomic particle has matter because we just defined particle as
matter is made up of particle
or energy.
It's a constituent of matter.
Don't act like you don't understand this, dude.
Do you know what the
okay? So a particle is
constituent mean?
Look how hard, bro. Okay, I don't understand.
Oh my God!
Why it takes
you guys
15 minutes to define your word.
This is
right
ridiculous.
the hand.
I'm telling you,
right the hand.
This is going on for
right
an
the
hour.
hand.
You can't define your words.
Right the hand. You tell us.
You guys are crazy.
Right the hand.
This is literally what you're doing. The topic subatomic particle comes up, and you insist on having particle being defined.
No, you.
I'm not done. When you say subatomic particle, you can't separate the words and give a definition for each one. They work together to form
a
definition.
The whole thing. Then define the whole thing.
They were trying to, but you will not listen. And this form of trolling of yours it's your topic. It's over.
Why do you need the definition for particle? Like you can talk about a grain of sand is a particle of sand. It depends on your context. We are in the context of subatomic particles because that's what you asked about when you were talking about photons.
Let me explain
so if you want to know about photons, we'll tell you about subatomic particles, and then we'll tell you about elementary particles, and then you can find out that they're a boson. And there you go. Or you can talk and talk and talk about us not telling you what a particle is when it's not relevant to the topic that you actually were asking about, and you're just trying to obfuscate.
Let me explain why it's relevant. Because at the end of what I was trying to get to was that you said that light is a massless particle. Now I'm trying to say that particle.
No, I didn't say it's massless. So it's matterless.
Oh, okay, so well, hold on. A photon, you're going to tell me, has mass now.
It's traditionally considered to have no rest mass, which is almost always what people mean when they say mass. It has inertial mass. I wasn't done. It does have inertial mass.
Okay, so when we rest mass is when you say mass, can we say it's a property of matter, right? We're talking about a conglomeration of matter in any capacity when you say mass.
No,
you're going to run into an issue because
bro,
you don't.
Come on,
different. Let me work with this.
You need inertia.
Different things can have similar properties. Mass has matter has the property of mass. Photons also have the property of mass. Okay. They don't have the property of rest mass.
Hold on, we're trying to just make it easy and clear. So mass is a property of matter.
It's not easy and clear.
Well, because you use 1,000 words. Is mass a property of matter?
Different things to talk about.
Okay, mass is a property of matter, right?
Yeah.
Yes.
Okay, so if you have a particle, you have matter.
No.
If it acts like matter, yeah.
Well,
the
problem is you just.
Let me give an analogy here.
You already know this.
Matter.
You already know this, you dumbass.
I need the definition. You just told me that a particle is a minute portion of matter, and then I said, okay,
no, I didn't.
Now is a. Okay, now we have to clearly define what a particle is again.
No, we don't.
You're literally repeating the Google definition as if somebody here said it to you when nobody. So you've forgotten where you got that information. So now you're trying to claim there's some sort of grand contradiction when there isn't. People have tried very patiently to explain to you the differences, the different sources of these words, but you keep saying, "Oh, but they're." It's like you're not fooling anyone.
Yeah, I highly suggest you go and you learn about inertia because
he left. Thank fuck.
Oh, thank God. I thought it was suspicious that he hadn't jumped all over me like within a second or two.